Okay, so by far the most requested tutorial was people were asking, how do you do the hidden function, right? So we have this thing, which we call the searching glass, and then it reveals a function, in this case the Arctic Monkeys logo, only while it's within the circle. So the first thing we're going to start with is the equation of a circle. Y squared plus x squared is equal to, okay, root 3, but whatever. We tied this to B and A, the x and y vertical and horizontal shifts, so that we could move the circle, right? The problem with Desmos is when it wants a restriction, it wants you to isolate for y or isolate for x. So we can't actually draw it like this. We have to isolate. So in this case, we have to say, let's actually copy this. First thing we're going to do is bring that to the other side. Positive becomes a negative. Yep. Okay. Next thing we have to do is this is a squared, so we have to turn that into a square root. So square root the entire thing. And then lastly, we have this minus b, and then a minus on one side becomes a plus on the other side. All right, there we go. See, it's only drawing the top half semicircle. The reason for that is because when you have a square root function, finding the square root of a number actually implies you're finding both the positive and the negative square root. In this case, because Desmos is a calculator, it only calculates the positive, right? But we'll get to that later. First thing we're going to do is the function that we're trying to hide. In this case, let's say, sine of x. And we say y is equal to sine of x. For those of you who are wondering how I did the Arctic Monkeys logo, Arctic Monkeys logo is just sine x times sine 25x, and you get that. So, yeah. But for the purposes of this, we're only going to be using sine of x. And let's say, let's make it 2x. Let's make it 3. So there we go. It's easier to see. So here we have a sine wave, and we have a circle that we can move around. What we're going to do is we're going to restrict it so that it only draws the sine wave. And this is the equation for the top of the circle. So long as y is less than the top of the circle. So first of all, it doesn't draw anything to the left or right because our restriction says look at the y value. So if it's less than the semicircle or the top of the semicircle, it'll draw it. If it's below it, it won't draw anything. As you can see, again, it only checks for, let's just make this 4. It only checks for above or below. So only if it's below it or above it, it's going to draw it. So this solves one problem, which is how you're going to make it hide it. But it only hides it what's below. So let's take this and let's find the negative square root. There we go, full circle. The positive and a negative. And now we just got to make the restriction apply to that too. So take the function, make it a second one, and flip it around. So this one says this is the equation of the top, and then this is the equation of the bottom, right? So it'll draw the black one so long as it's less than the top of the circle. It's going to draw the blue one so long as it's over the bottom of the circle. So now we have a problem. It draws it anyway, right? It doesn't take both into account. Actually, this is pretty cool because then you can make it like switch colors depending on how high this. That's actually, I'll find a use for that. Someone's gonna find a use for that. You know what? That's something you can do. But we have to make it so that it only checks for if it's below this, but within this. And the way you do that is less than or equal to b. And then this is also greater than or equal to b. So the way this works, So the way this works is it takes the b value, which is the y coordinate, and the first one says, okay, is y greater than b, right? If yes, then you'll draw it, right? And actually, if we remove this, it just checks is y greater than b. The second part is y less than the top of the circle? So if y is less than the top of the circle and greater than the middle of the circle, it'll draw it in black. The second part is it less than B? So it's going to draw it in blue if it's less in the middle, but greater than the bottom. And that's actually what it's doing. So on our actual CPT, it looks like it's one color. If you actually want to look at it, these are two different functions. Oh, it's lagging, isn't it? Yep. All right, there we go. It's actually, yeah, it's two different functions. We made them the same color so it looks more convincing. And same with all the dots. You see this, please? Yeah, these are actually two different dots. Because we need to put one for the top, one for the bottom. And that's one of the limitations of Desmos. So yeah, that's it. It just uses the restriction to determine if it's less than the top, greater than the middle, or less than the middle, greater than the bottom. And you can honestly hide whatever you want in there. Like let's say you wanted to hide a, I don't know, parabola. Y is equal to x squared. All you gotta, oh, that's capital Y. All you gotta do is make two of them. One of them where it's restricted for the top, and then one of them where it's restricted for the bottom. There you go. Hidden function. Obviously, if you want it to appear more convincing, you can make all of these the same color. So the top half of the function and the bottom half of the function are going to be the same color, and the circle is going to be all one color. So it leads to a slightly more convincing effect, as if you're only revealing a single function when you're actually revealing two. The last thing we did was we put in dots. So let's say we're going to put a point at 1, 1, and then let's just apply the restriction. Y. Ooh, you know what, actually? You can't use Y, so you just have to kind of use 1. So, there we go. Okay. X, there we go. Sorry, messed up. Okay, so basically, copy and paste that, and then flip these around. Oh, it took me a while to process that, but that is not what I wanted to do. What it does is you take the X coordinate and the Y coordinate, and in the actual restriction, you replace Y with your Y coordinate, and X with your X coordinate, and then you leave A and B alone, right? So what this does, it only draws that dot at 1, 1, so long as it's within the circle. Right, this has to be negative. There we go. And we just inserted a label, so let's make these the same color. And the label was secret here. No, that's not how it works. Clicked here, secret, here, secret, here. That's 1, 1. Oh, oops, I labeled the wrong one. There we go. So yeah, you don't have to use a circle. You can use any function, so long as your domain and range, or sorry, your restriction on all your other functions is that it's less than the top, greater than the bottom. And yeah, so you can use two parabolas if you want. You could use just a rectangle, right? It's just that with a circle, you have to do a little bit of weird stuff with rearranging the equation. But more or less, that's how we did it. We added an extra circle around it, where the restriction was it only draws this, it only fills it in so long as it's less than this circle. So it's greater than this circle and less than the bigger circle. And yeah, that's how we did it. Hope that helps and hope that explains a lot. And yeah.